Hi everyone, I am here today to clarify some of the question types and some of the learning objectives that you're going to see on your second lab practical in a couple weeks. Mostly the cardiac output stuff because this got covered in lecture, but I don't want to make you do math on lecture exams because calculators and 200 of you stress me out. So on the lab exam, these types of questions will appear. We're going to talk about those and pulse pressure and maybe a little bit about blood pressure. Okay, so define cardiac output. So cardiac output equals the amount of volume pumped by the blood, pumped by the ventricle each minute. And so mathematically, cardiac output equals heart rate times stroke volume. So a totally fair question on the practical would be you have a patient with a heart rate of 60 beats per minute. They have an end diastolic volume of 100 and an end systolic volume of 30, and those would be mils. And the question asks you to calculate cardiac output. So how do you do this? Well, first we need to figure out stroke volume. Stroke volume equals end diastolic volume minus end systolic volume. So in our case, that would be 100 minus 30 equals 70. And so we would take 60 times 70 and get 4,200 mils per minute. How did those units come out? Well, we had beats per minute and we had mils per beat. So we end up with mils per minute. You could also be asked to deal with just stroke volume. So you could be told that stroke volume is 100 mils, and systolic volume is 50 mils, and they could say how much blood was in that ventricle before it contracted, right? So you'd have to figure out that stroke volume is end diastolic volume minus end systolic volume. You would know 100 equals X, end diastolic volume minus 50, so you could figure out that our end diastolic volume would have been 150 mils. Those types of questions. One of the learning objectives for the cardiac phys lab was define mean arterial pressure and indicate how it is related to cardiac output. The TAs asked me about this one because there are a handful of other equations that we do not study in this course that relate to mean arterial pressure. The only one that you're responsible for knowing is that mean arterial pressure equals cardiac output times peripheral resistance. And if this sounds unfamiliar to you, go back to the slides where we have the heart pumping a number of times and filling up blood vessels with drops of blood. We also looked at it from the standpoint of the vessel. If we made the vessel smaller or bigger, or we changed how fast, heart rate, or how much, stroke volume, that would change mean arterial pressure. So that's the only equation we are working with for mean arterial pressure. Pulse pressure. Define and calculate pulse pressure. List locations on the body where pulse can be palpated or can be detected. So pulse pressure just means systolic minus diastolic pressure. So if we have a patient whose blood pressure is 120 over 90, they're a little hypertensive, their pulse pressure would be 120 minus 90 equals 30 millimeters of mercury. Remember, a pulse pressure is just what we can feel due to the difference in arterial pressure between systole and diastole. And then real quick, what kind of questions might you have to answer related to volumes and capacity? So this is also related to questions involving calculators. We didn't cover this at all in lecture. You only covered it in lab. And so your TA could probably give you a little bit more information about the types of questions that they like to write about this. But they could ask you to read a graph like this. So they could have none of this information here. And they could say, based on this graph, calculate tidal volume. The y-axis is not labeled. Great for you to be able to do that here. They would have to show you like, oh, this is like 2250 and 2750, and so you could know that if we're just going from here to here with one normal breath, that tidal volume here would be about 500 mils. They could give you values for things like maximum inspiration and maximum expiration and tidal volume, and ask you to calculate things like expiratory reserve volume or inspiratory reserve volume. They could ask you to do a little bit of math regarding that. And then define and list normal values for respiratory rate, minute volume, alveolar ventilation, and dead space, just to make sure we all have the same equations. Respiratory rate is just the number of breaths per minute. And this you would just observe the patient and count their breaths in order to measure this. The normal rate is about 12 breaths per minute. The the minute volume, this is how much air is moving in or through the respiratory tract each minute. So this is tidal volume times respiratory rate. So if we have a normal tidal volume of 500 and a normal respiratory rate of 12, that would give us about 6,000 mils per minute or 6 liters per minute. The difference between minute volume and alveolar ventilation is the fact that alveolar ventilation takes into account dead space. So not all of the air that's going in and out of the respiratory tract can participate in gas exchange due to the fact that we only have a portion of the respiratory system that is the respiratory zone. So alveolar ventilation is tidal volume minus dead space times our respiratory rate. So if we have 500 minus, 200 mils of dead space times that same 12, 300 times 12 equals 3,600 mils per minute. So your alveolar ventilation is always going to be less than your minute volume because it takes into account dead space. All right, that's all. If you have any additional questions about these question types or anything else, please feel free to contact me or your individual lab instructor about them. Happy studying!